Magnetic effects of electric current, sir. ఇదే డీటెయిల్ వీడియో, ఇదే వన్ షాట్ వీడియో. ఓకేనా? ఆల్రెడీ ఇన్న వాళ్ళు ఎంతమంది ఇక్కడ? మ్యాగ్నెటిక్ ఎఫెక్ట్స్ ముగ్గురు. అంటే మిగతా వాళ్ళందరికీ మ్యాగ్నెటిక్ ఎఫెక్ట్స్ కొత్తనే. చలో. సో మన ఎలక్ట్రిసిటీ చాప్టర్లో ఏం నేర్చుకున్నాం రా? ఏం ఎఫెక్ట్ నేర్చుకున్నాం ఎలక్ట్రిసిటీ చాప్టర్లో? Which effect did we learn in electricity chapter? Electric effect and heating effect. Yes or no? We have calculated power, current bill, etc. Okay. So these are the things we have understood in electricity chapter. So here what we are trying to understand, we are trying to understand about magnetic effect of electric current. Today, even if the session gets extended, we will try to complete this topic. We will try, and let's hope, because the time is already 8:20. So we'll only continue till 9, 10, maximum 9:15, and we'll try to wind up the session.
Part 2.
That's what I'm planning. No need of part 2. Only part 1 we have to wind up. Okay? So, magnetic effect. Okay? First, till the age of Oyster, we only thought that electricity is completely different and magnetic effect is completely different. These both are completely different. After the Oyster discovering this accidental discovery, later we understood, oh, this magnetism and electricity both are one and the same. Clear? We have an electron with us. If this electron is at rest, it shows electric effect. And when this electron starts moving, it not only shows electric effect, it also shows magnetic effect. What does it show, sir?
Magnetic effect.
Who will show magnetic effect? When the electron is moving in a wire or a circuit, then it shows you magnetic effect. Clear, Mr. Bhargav? So now we'll start with Oyster experiment. What did Oyster have done? See, initially he set up all the scientists like this in a big hall. He is conducting some kind of experiment. So he is doing some work on some potentiometer, voltmeter, etc., etc. And there is a compass which laid on the table where he is doing the experiment. So the setup is like this. The compass is at the bottom and there is a wire at the top. Clear, sir? Now this is the bottom. Now what you see, sir? You see only a side view of the compass. When you see the top view of the compass looks something like this, and it is north, south. Clear? Is that clear, all of you? Clear?
Yes, sir.
Now, when the current is passing from one side to another side, like from one terminal to another terminal, he accidentally observed this compass needle is getting deflected. Deflected means it's just moving front and back. It's waving here and there. Okay, Nara?
Yes, sir.
So this is what observed by the Oyster, and he said all the scientists to leave, and he did several experiments. He came up with certain rules and regulations, and he came up with a new invention. Found what is that, sir? That is, the current can also show magnetic effect. So he gave us a rule called snow rule. What did he give us, sir? Snow rule. What is that? When the current is, so first of all the setup, look at the setup. The wire is on the top. The wire is on the top. At the bottom, compass is there. Clear, sir? So this is south side, south direction, and here it is north direction, and the compass at the bottom. Clear? The compass needle is like this now. When the current is flowing from south to north, when the current is flowing from south to north, then the needle will deflect towards west. Am I clear? When the current is flowing from south to north, the needle will deflect towards the west. That is snow rule. Look at the setup once again. The confusion comes in the setup itself. Look at the setup. Wire is at the top. And the current is flowing from where to where, sir? Important. South to the north. Here south is not south pole, north is not north pole. South direction, north direction. When the current is flowing from south to north direction, then the needle will deflect towards west. The question is, what is if current is coming from north to south? It will deflect towards east direction. When it is coming along, when the current is going in that direction, it is deflecting west. When the current is going like this, it is deflecting east. From this concept of snow rule, they have invented the new rule called as right hand thumb rule. What is that, sir?
Right hand thumb rule.
Right hand thumb rule. So what does this right hand thumb rule says? The current is flowing. So point your thumb towards the direction of the current. Thumb towards the direction of current. Curl your fingers. The finger shows the direction of a magnetic field. What is the concept, sir? Point your thumb towards the direction of the flow of current. Close your fingers. The fingers will show the direction of the magnetic field. From this you observe here, let us say the current is going along this direction. At the bottom, where the magnetic field is showing, sir, towards the west only, na? So snow rule is verified here also. Am I clear, sir? If the current is going along this direction, now which direction the magnetic composite will deflect? Towards east. Understood, sir? Understood? Based on this concept, they will frame questions. So that is why even before properly explaining about all this stuff, I have directly given you this. So what is right hand thumb rule? Point your thumb towards the direction of current. Close your fingers. The fingers will show the direction of the magnetic field. Magnetic field? What is magnetic field? The imaginary area around the magnet is known as magnetic field, where the effect of magnet is felt. The imaginary area around the magnet where the effect of magnet. What is the effect of magnet, sir? If you put one magnetic substance, it will be getting attracted. Yes or no, sir? Yes or no? Any doubts?
Yes, sir.
Now we have to talk some important properties of magnetic field. There are 3 or 4 important properties of magnetic field. The first important property. So till now we know about magnetism related to some bar magnet, horseshoe magnet, etc., etc. Correct? Correct or not?
Yes, sir.
So from today onwards, we will be studying about the magnetic effect produced by the current. But first we'll try to analysis regarding this magnetic field with the help of the magnet itself. Chalo, we'll start. Am I raising the board? So this is our magnet. Let us assume this is North Pole and this is South Pole. You break this magnet into 2 pieces. Then what will happen? Can you create a monopole?
No.
Monopole is never possible. Always you have dipole. What do I mean by dipole? Let us say I have broken this into 2 pieces. Then what will I get? Here north, south. Again. Am I clear, sir? Any doubts? So like this, always there is dipole. Next, let's talk about the important properties. This magnetic field is not just an imaginary area. These are comprised of some lines which come out of the magnet and enter back into the magnet. field lines. We call them as field lines. From where they will come, sir? From outside the magnet, they will come out from the north pole, and inside they will travel from south to north. That is one magnetic field line. From where it is going, sir? From the north. Outside the magnet, the field line is going from north to south. Inside the magnet, the field line is going from south to north. Here the common question, sir, only one line will be there, sir. No, sir. Just imagine, if this is a magnet, from this infinite number of lines will come out in 360-degree directions, and again they will all enter back into the south, and this continuously happens.
Sir, they go under the magnet also. Up.
Yeah, field lines travel inside the magnet as well. But because it is solid or opaque substance, you can't exactly identify. Now you can take a compass and you can do a basic experiment. Take the compass, put the compass in front of the magnet, the magnetic needle diffracts in this direction. Okay. How to know that this is a magnetic field line? How do you know, sir? It's very simple. Take the magnet. Here north pole is there, south. Here you place a magnet. Then what will happen, sir? It will deflect like this. Keep any one point. Again you place one more compass there. Then it shows like this. Drag a point. Exactly at that point, keep one more. Shows like this. Point. One more. Show like this. So if you collect all these points, show like this. Now here, what this magnetic compass is pointing towards? North direction. North pole. Not to a north direction. It is north pole. This pole is related to magnet. North direction is just a direction. It's not related to magnet. North pole and north direction, two different things. Am I clear, sir? So what this needle is showing, sir? It is showing you the north pole at that point is along that direction. So this guy is saying, sir, north pole is here. Here, U-turn. Here, like this. So like this, when you collect all these points, what do you get? You get a magnetic field line. And when you place a magnet here, what it will show? Into the magnet. So you place a magnet compass on the magnet, then it will show like this. Like this. So from this what we can see? We can confirm, yes, the magnetic field lines are passing from south to north inside the magnet. Through this we can confirm. Clear, sir? Doubts? Chalo next. This is the first property. What is the first property, sir? Field line will come out from the north pole. It travels from north to south outside the magnet, south to north inside the magnet. Chalo. Next, it is regarding the strength of the magnet. What do I mean by strength of the magnet? A magnet can attract different magnetic substances. How much attraction force it can apply? Can it apply this much, this much, this much? What about the magnitude of the magnetic force applied? That magnitude of magnetic force is what I am asking. ఒక మ్యాగ్నెట్ చిన్న మ్యాగ్నెట్ని గుంజవచ్చు, ఇంత చిన్న రాయిని గుంజవచ్చు, మెయిన్ చిన్న ఐరన్ బార్ని గుంజవచ్చు. అంతకుమించి గుంజగలుగుతుంది సార్ చిన్నది. దాని స్ట్రెంత్ పెంచుకుంటూ పోతే మేబీ ఎస్ ఆర్ నో. ఇక్కడ మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్ దేనికి హెల్ప్ చేస్తుంది సార్? ఇట్ విల్ అట్రాక్షన్కి హెల్ప్ చేస్తుంది. ఎంత ఎక్కువ మాస్ ని దాని వైపు పుల్ చేయగలదు. ఇట్ ఇస్ టాకింగ్ అబౌట్ ద ఇంటెన్సిటీ ఆఫ్ ద మ్యాగ్నెటిక్ ఫీల్డ్ అనొచ్చు, మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్ అంటారు. ఇవన్నీ కూడా ఒకటి. క్లియరా? నౌ ద క్వశ్చన్ ఇస్, సార్, bar magnet is here, where the magnetic field strength is more, where the magnetic field strength is less. More near the poles, less near the center. Why? Look at this. Let us draw the magnetic field lines along one direction. So this is our magnet, north, south. The field lines have come like this. Here again the field lines came. The relative closeness of the magnetic field strength, field lines, is directly proportional to field strength. Field lines ekkadaithe దగ్గరగా ఉంటాయో, if the field lines are closer, and crowd ఎక్కువ ఉంది ఇక్కడ. If you observe carefully, at this area or region is where more number of field lines are present. So here magnetic field strength will be more. If you observe here, there are less number of field lines are there near the center of the magnet. So magnetic field strength is less. Now again, if you see this point, field strength is more compared to this point, because at this point zero number of field lines are there, but here yes, some more field lines are nearby. Am I clear, sir, regarding the magnetic field lines and field strength? ఫీల్డ్ లైన్స్ ఎక్కడైతే క్లోజ్గా ఉంటాయో అక్కడ మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్ ఎక్కువ ఉంటుంది, ఎక్కడైతే దూరంగా ఉంటాయో అక్కడ మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్ తక్కువ ఉంటుంది. నెక్స్ట్, రిగార్డింగ్ ద సేమ్ మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్, if you go away from the magnet, the field strength will decrease. If you come towards the magnet, the field strength will increase. This is regarding field strength. Am I clear, sir? 2 points. Now the third point is very important. What is the third point? Have you ever observed that, okay, here it is clumsy, but generally if you observe, no two magnetic field lines will intersect or cross. Why? See, if I place a compass exactly at this point, will it show two magnetic north poles? No, it cannot show two magnetic north poles. It's not possible. And that is the reason why no two magnetic field lines will intersect at any point. Never ever two magnetic field lines intersect at any point. Understood, sir? If at all they are intersecting, what does it mean? It means that at a single point there are two magnetic north poles, which is not possible. Am I clear, sir? These are the 2 or 3 main important properties of magnetic field that you need to remember. Clear? Am I clear, sir?
Sir, SI unit, what is the SI unit of magnetic field?
It is SI unit of magnetic field. So it is not there in the textbook. Tesla. The answer is Tesla. Okay? And now force, regarding force, again it's a different story. Field, it's a different story. I'm talking about field strength, Tesla. Force, of course, all the units of forces are newtons, etc.
సార్ రెండు మ్యాగ్నెట్స్ ని ఆపోజిట్ పోల్స్ లో అట్రాక్ట్ అవుతాయి కదా, అప్పుడు ఫీల్డ్ లైన్స్ టచ్ అవుతుంది.
Yes, they will intersect.
మరి అప్పుడు
ఇక్కడ నేను ఏమంటున్నా, here for a same magnet field lines will not intersect.
డిఫరెంట్ మ్యాగ్నెట్
For a different magnet, yes, of course it can be, because this field line are like this field line is of that particular magnet, that field line is this magnet. When they both come towards each other, yes, in that case field lines will interact. In that case it is possible, but there we talk about different phenomena like cancelling of the magnetic effect or adding up of the magnetic effect. Last year 2023 also there is a question based on it. We'll talk about it little later, but the point here is field lines interaction for a same magnet they will never interact or intersect. For two magnets, yes, they will intersect
Sir,
when you place nearby.
sir, magnetic field is vector quantity.
Yeah, it's a vector quantity. Why it is a vector quantity? Any field is a vector quantity because it has both magnitude as well as direction. What is magnetic field intensity? It is magnitude. At that point, this field is acting along one direction. See, I said north poles are acting along one direction. Yes. Clear, sir?
Yes.
Now we'll come back to CBSE class 10 and talk about CBSE class 10. Okay.
Sir, till now,
They have debated some Olympiad questions they asked. Fine. Field line story clarity, sir? Now, once again, we'll go back to the wire current right hand thumb rule. What is that? This is a wire. So this is wire is going like this. It's an infinite straight current carrying conductor. Let us imagine like this. Okay? Okay, sir. Now in this, the current is going like this, up. From one direction to the other direction, the current is going. Now, if the current is flowing in a wire, we know that immediately there is a magnetic field around it. Yes or no? Now, how to find the magnetic field direction and all? Right hand thumb rule is there, sir. But how to verify it? How to verify it? With the help of the compass, and also there is another process by throwing some iron fillings on it. When you throw the iron fillings on it, you can see that all the fillings are framing themselves into concentric circles. That is one way. But even though they are aligning themselves into concentric circles, there is a problem. What is it? You can't talk about the direction. Yeah, they look like concentric circles, but direction you cannot talk through the magnetic filings. I mean iron filings. Then what to?
Right hand thumb.
Arey, how this right hand thumb rule invented? Clear? That is the idea. What we'll do? We'll take a cardboard. Here we'll arrange one cardboard. Here we arrange another cardboard. Here we arrange another. So we have arranged 3 cardboards. Randomly pick any one card. Okay. Randomly pick any cardboard and draw the top view on it. What is this? This is a top view. So here is the center. That is the center. That's a point where wire is coming out. Okay. So here we have a cardboard and we are showing a top view, and it's the center where the wire is going like this. Correct or wrong, sir? Sir, why sir wire you have shown the point? Ante kada wire itla petti chusna anko. What do you see? You see a small point, right?
Yes.
Otherwise, sir. Fine. So now what I did, sir, I placed a compass here. Initially, I have switched off the circuit. Current is not passing, sir. When the current is not passing, all the compasses align themselves into original north and south direction. Like this they have aligned. Immediately, when the current start passing, in which direction the current is going, sir? It is going outward. Where it is going, sir?
Outward.
Now, because I am watching the top view. Top view means here the current is going outside. So in the top view the current is coming like this. Am I clear? When the current is coming like this, immediately if you look at the compass, the compass needles are deflected and they themselves join into this particular direction. How are they showing up? They are showing at a circle. Now that circle also there is a direction, proper direction. What is the direction, sir?
North to west. South.
North to south, okay. But is it clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise or clockwise? How to identify whether something is clockwise or anti-clockwise? Again, I am telling you. Just stretch your right hand. Imagine that there 12 o'clock is there. Correct or wrong, sir? Here it is 9 for me. Here this is 3 for me. For me here 3 o'clock. For me here is 9 o'clock. Now when I curl my fingers from the 12, it is going towards 9, which means the direction is along anti-clockwise. Now here from the 12, if I am curling my fingers along 3, it means clockwise direction. 12 to 9 anti-clockwise. 12 to 3 clockwise. Am I clear? Now here if you see, upwards I have stretched. So 12 is up. From up, it is going towards 9.
Clockwise.
So it anti-clockwise. Am I clear, sir? Am I clear? Any doubts? Any doubts? So here when the current is coming in outward direction, the field lines align themselves in a anti-clockwise direction. Sir, ఇంటి ఒకటే లైన్ ఉంటుందా మరి? No, actually ఎలా ఉంటుందంట? See, let us draw one more cardboard. So this is center, this is the first top ones, and there is another circle, but the direction is anti-clockwise. Am I clear, sir?
Sir, ACW and
Anti-clockwise. So right hand thumb rule. What does right hand thumb rule say, sir?
Direction of
Shows
the
Thumb.
shows the
Shows
direction.
So the point your thumb towards the direction of the flow of current. Close your fingers. It will show you upward anti-clockwise, downward clockwise. Katham. Now to confuse you, what they'll do? They'll not give you current. They'll give you the flow of electron.
Sir, okay.
flow of current.
Yesterday we already saw the direction of the flow of electrons is opposite to the direction of flow of current. If the electrons are going in upward direction, where the current is going? Downward direction. The current is going in downward direction. So the magnetic field lines are clockwise. So your magnetic field lines are clockwise. This is a right hand thumb rule story. మొత్తం అర్థమైందా సార్? డౌట్స్ ఉన్నాయా సార్? చలో ఫాస్ట్.
Side flow, like
సైడ్ ఫ్లో అయింది. ఇప్పుడు ఎత్తున్నా, ఇప్పుడు ఇటు సైడ్ పోయింది. కర్ల్ యువర్ ఫింగర్స్. సో ఇటు పంపించా. ఇటు పంపించినప్పుడు ఏమైంది? నీకు క్లాక్ వైజ్ యాంటీ క్లాక్ వైజ్ అడగడు వాడు. అర్థమైందా? ఇటు పంపించినప్పుడు వాడేమంటాడు అంటే నువ్వు వెనకాల నుంచి చూస్తున్నావు, ముందు నుంచి చూస్తున్నావు, చెప్పు నువ్వు ముందు నుంచి చూస్తే అది క్లాక్ వైజా, వెనకాల నుంచి చూస్తే నువ్వు క్లాక్ వైజా, ఇలాంటి క్వశ్చన్ అడుగుతాడు. సే లెట్ us say the current is going from ఇది క్వశ్చన్ రాసు ఏంటిది కరెంట్ ఈస్ గోయింగ్ ఫ్రమ్ సౌత్ టు నార్త్.
Sir, textbook question, sir.
ఏమంటున్నాడు? ద కరెంట్ ఈస్ గోయింగ్ ఫ్రమ్ సౌత్ టు నార్త్. యూఆర్ లుకింగ్ అట్ ది కరెంట్ ఫ్రమ్ ద బ్యాక్ సైడ్. వెనకాల నుంచి చూస్తున్నావు అంటే ఇక్కడ నుంచి చూస్తున్నావు. చెప్పు నీకు కరెంట్ యాంటీ క్లాక్ వైజ్ కనిపిస్తుందా, క్లాక్ వైజ్ కనిపిస్తుందా? క్లాక్ వైజ్. సరే మరి ఇప్పటి నుంచి ఇక్కడ చూస్తే యాంటీ క్లాక్ వైజ్. అర్థమైందా? ఇటు చూస్తేనేమో క్లాక్ వైజ్ కనిపిస్తుంది, అదే నాకు ఇటు చూస్తేనేమో ఏం కనిపిస్తుంది సార్? యాంటీ క్లాక్ వైజ్. అర్థమైందా? డౌట్స్ ఉన్నాయా? డౌట్స్ ఉన్నాయండి? సో ఇలా క్వశ్చన్స్ కూడా మనం ఫ్రేమ్ చేసుకోవచ్చు. సేమ్ సింపుల్ రైట్ హ్యాండ్ థంబ్ రూల్ మీద. ఈ రైట్ హ్యాండ్ థంబ్ రూల్ ఇంకో దానికి మనకు వస్తుంది, అది మనం కాసేపు ఆగి దాని సంగతి చూద్దాం.
So what about left hand?
Now the question comes, left hand thumb rule you want, huh?
Yes.
Only thumb is enough or
Left hand rule, sir.
Left hand.
left hand rule is there,
Oh, sorry sir,
But-
I was confused.
left hand thumb rule is not there, but this left hand thumb rule comes at the end of the chapter. I think it will take two parts.
Sir, చేతులు ఏమో ఇది సార్.
Huh?
చేతులు ఏమో.
Left hand leg rule.
ఇది వేరే ఎగ్జామ్ ఎలా రాస్తాడు ఫస్ట్?
Scribe.
అప్పుడే దాంతోనే చూసుకుంటా.
అరే నువ్వు కంటామినేట్ అయినావని అందరు కంటామినేట్ అవుతారు అనుకున్నావా?
సార్ వ్యూవర్స్ ఏమంటున్నారు సార్ అది విని?
అర్జున్ గాడు కంటామినేట్ అయినా
పేరు వాడేసి.
Vignyan School, A3.
Vignyan is
Vignyan
basic.
contaminated guy.
మనకంతా ఫాలోయింగ్ లేదా? ఇప్పుడు వాళ్ళందరూ వచ్చి సబ్స్క్రైబ్ ఫాలోయింగ్ పెరిగినప్పుడు నువ్వు బాగుపడాలి. ఇప్పుడు ఎందుకు బాగుపడాలి?
ఎన్ని సబ్స్క్రైబర్స్ ఉన్నారు సార్?
2K.
2K సార్. వాట్ ఇస్ సార్? పరుదియా.
100 మంది ఉన్నారా?
వాట్ ఇస్ సార్? పరుదియా.
100 మంది
ఆ వార్త బట్టి ఒక్కొక్కటి చెప్తే
ఉండాలి కదా పరువు కూడా. లక్ష్యం కాదు.
చాలు ఇక సార్. ఇప్పుడు బార్ మ్యాగ్నెట్ కో నార్త్ పోల్ సౌత్ పోల్ ప్రాపర్ ఉంది. ఇక్కడ మనం మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్ చూస్తున్నాం. కాన్సెంట్రిక్ సర్కిల్స్. నార్త్ పోల్ ఏడుంది, సౌత్ పోల్ ఏడుంది, అసలు నార్త్ పోల్ సౌత్ పోల్ స్టోరీనే లేదు ఇక్కడ. ఇక్కడ ఇప్పుడు నాకేం కావాలా? సమ్హౌ బార్ మ్యాగ్నెట్ ఎట్లయితుందో నాకు కూడా అట్లనే ఒక ఎలక్ట్రో మ్యాగ్నెట్ తయారు చేయాలి, సచ్ దట్ వాడికి కూడా ఒక నార్త్ పోల్, వాడికి కూడా ఒక సౌత్ పోల్ ఇట్లా ప్రాపర్ ఉన్నాయి. మరి దానికి ఏం చేయమంటారు? క్వశ్చన్ అర్థమైందా?
yes sir.
ఏంది క్వశ్చన్?
అంటే కాన్సెంట్రిక్ సర్కిల్ లో
డైరెక్షన్
I can't notice that
మనం
different magnet.
కరెంట్ క్యారింగ్ వైర్ స్ట్రైట్ ఉంది, కరెంట్ క్యారింగ్ వైర్ స్ట్రైట్ ఉంది. దాని చుట్టూ మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్ కాంటాక్ట్ సర్కిల్స్ లో తిరుగుతున్నాయి. సో ఇప్పుడు నార్త్ పోల్ ఏదనుకోవాలి, సౌత్ పోల్
నార్త్
ఏదనుకోవాలి?
పోల్ టు సౌత్ పోల్ ఉంటుంది సార్.
ఏడ నార్త్ పోల్ టు సౌత్ పోల్ అయిందా?
డైరెక్ట్
అది పోల్స్ కావాలి, మళ్ళీ చెప్తున్నా డైరెక్షన్స్ ఆర్ డిఫరెన్స్ అండ్ పోల్స్ ఆర్ డిఫరెన్స్. ఇందాక సౌత్ నార్త్ రాసినాయి, సౌత్ డైరెక్షన్ నుంచి నార్త్ డైరెక్షన్ కి కరెంట్ పోతుంది అని రాసిన. సౌత్ పోల్ నుంచి నార్త్ పోల్ కి కరెంట్ పోతుంది. మ్యాగ్నెట్ లో కరెంట్ పోవడం ఏంటి? చెప్పండి. ఫైన్ ఇక సార్. సో ఇప్పుడు ఏంటంటే స్టోరీ, వైర్ యూజ్ చేసి నార్త్ పోల్ సౌత్ పోల్ ఇట్లా. సో we also want north pole and south pole. Look at this. For that what they did, all the researchers, they have bent the wire and made it in a shape of a circle. ఎట్లా చేసారు దాన్ని?
Shape of circle.
Here the current direction is upward and again here the current direction is at downward. Right. ఇక్కడ కరెంట్ డైరెక్షన్ ఎటుందిరా? పైకి. ఇక్కడ పాజిటివ్ నెగటివ్. ఎనీ ప్రాబ్లమ్ సార్? ఎనీ డౌట్ సార్? అఫ్ కోర్స్ ఫ్రమ్ ద పాజిటివ్ టర్మినల్ ద కరెంట్ విల్ కమ్ బ్యాక్ టు ద నెగటివ్ టర్మినల్. ఫైన్. నా ఇక్కడ చెప్పండి మ్యాగ్నెటిక్ ఫీల్డ్ లైన్ డైరెక్షన్ ఎట్లా ఉంటుంది? ఎలా ఉంటుంది సార్? యాంటీ క్లాక్ వైజ్ అంటే సో ఫీల్డ్ లైన్స్ అన్ని ఇలా బయటకు వచ్చి ఇలా లోపలికి వెళ్తున్నాయి. Yes or no? They are coming out like this and they are entering into it. మరి ఇక్కడ clockwise. Obviously, yes, clockwise. అంటే ఇక్కడ నుంచి ఫీల్డ్ లైన్స్ ఇలా బయటకు వచ్చి ఇలా లోపలికి వెళ్తున్నాయి. బయటకంటే బోర్డ్ నుంచి బయట. The field lines are coming out like this and entering like through this wire, not from my face. So the field lines are coming in. 3D చూపించాలి కదా, అందుకే ఇట్లా కిందకి బెండ్ చేసి రాస్తున్నాం. సో ఫీల్డ్ లైన్స్ అన్ని ఇలా బయటకు వచ్చి ఇక్కడ సైడ్ నుంచి లోపలికి వెళ్తున్నాయి. మనకి బార్ మ్యాగ్నెట్ లా ఏ పోల్ లో నుంచి ఫీల్డ్ లైన్స్ బార్ మ్యాగ్నెట్ లోపలికి వెళ్తారు? సౌత్ పోల్. అంటే ఇప్పుడు నాకు కనిపిస్తుంది ఏం పోల్? ఎందుకు సౌత్ పోల్? అది ఫీల్డ్ లైన్స్
బయటకు వచ్చి లాగుతుంది.
క్లియరా సార్? The field lines are coming because by respecting the right hand thumb rule, the field lines are coming like this. From here also field lines are coming. Yeah. So the same wire, when you bend it and connect to positive terminal and negative terminal, and with the current direction, look at the current direction. In which direction the current is flowing? Clockwise. The current is flowing towards clockwise. If the current is flowing in a clockwise direction, that phase, a wire, that phase itself is south pole. Now when I am watching like this, now I took the wire and I placed it in front of me. For you guys, where the field lines are coming, sir? Like this. For me, when I am watching it, they are coming out of it. So I am watching north pole and you guys are watching south pole. Am I clear, sir?
Yes, sir.
ఇక్కడ నుంచి సౌత్ పోల్ నాకు నార్త్ పోల్. అండర్స్టూడ్ సార్? సో దే ఆర్ ఎంటరింగ్ త్రూ సౌత్ పోల్ అండ్ ఎగ్జిటింగ్ అవుట్ ఫ్రమ్ నార్త్ పోల్. అంటే సింపుల్ వైర్, దిస్ ఫేస్ ఇస్ యాక్టింగ్ లైక్ ఎ సౌత్ పోల్ అండ్ దిస్ ఫేస్ ఇస్ యాక్టింగ్ లైక్ ఎ నార్త్ పోల్. Am I clear?
Yes.
So for me, when I look at the current direction, it is not clockwise but it is anti-clockwise because the current is flowing like this for me. For you guys it is flowing clockwise. For me it is anti-clockwise. When the current is flowing in anti-clockwise direction, that phase will behave like a north pole. When the current is flowing in a clockwise direction, that phase is behaving like a south pole. Sir, anti-clockwise, clockwise, this is very confusing. So simple trick is this. What is the trick? This is also known as, I think, clockwise rule or whatever. So write S. S I have written. Look at the edges of the S. Put the arrow like this. Okay. The same arrow you place them like this also. Now how does the arrows pointing? Like
Clockwise.
with clockwise or anti-clockwise?
Clockwise.
It is pretty clear, it is clockwise. Not N. Look at the arrows. Clockwise or anti-clockwise?
Anti-clockwise.
So the current direction, when the current direction is in clockwise, then what I am getting, sir? I am getting a south pole. When the current direction is in anti-clockwise direction, that side, what I am getting, sir? I am getting a
Anti-clockwise.
It is that simple. Am I clear, sir? So now we have achieved to manufacture anala, produce anala, emana. So now we have achieved the north pole and south pole with the help of a current carrying conductor. What is this current carrying conductor? A wire. That's it. To make it complicated, we call it straight current carrying conductor. It's a wire.
That's all.
But without insulation. Here this wire has complete insulation, but this wire does not have. It's copper wire. That's it.
So we can
Clear? Doubts?
Sir, from insulation wire also we can find magnetic field.
Answer check. Maybe yes. Problem is there, sir. Here. The problem is this is not even attracting my bike keys. This wire. See? That is the problem, sir. Reason. What is the reason? The reason is the magnetic field strength is very minute. Now the question comes: how to increase the
increase the current,
magnetic field strength?
By increasing the current.
increase the number of turns.
So now we'll see that. How to increase the magnetic field strength of this guy. So the question. Now I took a complete big wire. I have curled into it a single wire like this. Correct? Now only one time the current is flowing. Only once current is flowing. So it is acting like a single magnet. Now if I try to increase the number of turns like this, then how many times the current will flow, sir? Once, twice. Now if I further increase this to 3 times, 4 times,
Twice.
5 times. So the current number of turns, how many turns I turn it, that many times the current will flow. So everything will act like a single wire. So this is one magnet, this is another magnet, this is another magnet. This is one magnet, this behave like a different magnet, and this guy behave like a different magnet. So like this, all the currents, like 3 different magnetic field strengths it obtains. Like the simple point I wanted to tell you is to increase the magnetic field intensity of this copper wire. I mean this wire. What you have to do, sir? You have to increase the number of turns. When you increase the number of turns, then what will happen, sir? The magnetic field strength will increase. First point. And the second point is pretty basic. Number of turns and number of turns and so we call this as a loop, coil, number of turns. Particularly number of turns and technically. The other way is already that current increase the magnitude of the current flowing through this wire. Am I clear, sir? More the current, more the magnetic field. More the number of turns, more the magnetic field. That's it. Doubts? Understood? How to increase the magnetic field intensity?
Yes.
2 ways. One is to increase the number of turns. Second one is allow the more current to pass through. Increase the magnetic field intensity. Increase. Sure. Next. Sir, everything is happy now? Like we have achieved our north pole and south pole, but still there is a problem, sir. Problems are problems. It's not a problem, sir, actually. Sir, look at the bar magnet. Length is there. See, there is a length of magnetic length. But for this coil, where is the length, sir? If I simply wind it, what I see a straight line. Loop మొత్తం ఇట్లా అరేంజ్ చేసి పెడితే నాకు ఏం కనిపిస్తుంది? నాకు స్ట్రైట్ లైన్ కనిపిస్తుంది. Where is the length, sir? Don't worry. Arrange the wire in the form of a spring. How does the spring look like? Coil. Coil. So it looks something like this, right?
Yes.
Connect it to a cell. That's it. So first of all, trick. Where is the north pole and where is the south pole? For a bar magnet, we know that here north, here south. We can find it.
Positive side.
For this guy, where is the north pole and where is the south pole?
Positive side.
Simple trick to remember. Wherever negative terminal is there, negative terminal. If you join that, here you get your north. Obviously, that is north pole. Here, what you get, sir? South pole. That is a trick to remember. That is not how you decide and show what is the magnetic field. That is just a trick. సార్ పాజిటివ్ వైపు సౌత్ అది గుర్తుపెట్టు కానీ ఇక్కడ పాజిటివ్ సౌత్
నెగిటివ్
నెగటివ్ నార్త్ ఎన్ ఎన్
ఓకే
అట్లా ట్రిక్
ఇండియా
అరే పాజిటివ్ కి సౌత్ కి సంబంధం ఏం చెప్పు
అట్లానే కాదు, ఇలా రెండు గుర్తు పెట్టుకున్నాం నార్త్ అని ఇండియా వస్తుంది కదా, ఎక్కడ కరెక్టే వస్తుంది సరే మన నార్త్ అని పెట్టుకుంటాం.
Sir, South Indians positive ఉంది.
అంతే సౌత్ ఇండియన్స్ అది మీరు అర్థం చేసుకోండి. అదే సార్ నాకు
ఇట్లా మళ్ళీ నా ఫాలోవర్స్ మొత్తం ఫారినర్స్ ఉంటారు కదా మరి వాళ్ళు ఫీల్ కాదు అట్లా అంటే
ఆల్ గైస్
తక్కువ ఉండేవాడిని నీకు తెలుసు.
సరే చూడండి
అర్జున్ వాళ్ళే ఫీల్ అయితే వెళ్ళిపోవచ్చు.
ఇక్కడ మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రెంత్ ఫీల్డ్ లైన్ గురించి చెప్పడానికి మనకు వచ్చింది మళ్ళా రైట్ హ్యాండ్ థంబ్ రూలే. ఎట్లా సార్ లుక్ లుక్ ఐ నో ద కరెంట్ విల్ ఫ్లో లైక్ దిస్. So it's flowing like this again. Now what you do, you curl your fingers in the direction of the current. What you do, sir? Curl your fingers in the direction of the current. The thumb will point to the north pole. Simple enough, sir. Curl your fingers in the direction of the current. The thumb will point the north pole. That's it. So this is the second use of right hand thumb rule. What is the first use of right hand thumb rule? Point your thumb in the direction of current. Curl your fingers, gives you magnetic field line. There, fingers are giving you magnetic field line. We have to point the thumb in the direction of current. Here, fingers should be used to show the direction of current. Thumb will show the north pole. Where exactly is the north pole?
from now
Am I clear, sir? Now
go there.
clear? Can you repeat that?
Fingers side current.
So if you observe carefully, the current is flowing along the anti-clockwise direction. Sorry, clockwise direction. So from the back side, what I see clockwise.
Magnetic
Correct or wrong? Clockwise. In clockwise, what I can see south pole here. So obviously, the person who is watching from here, he see anti-clockwise, which means he can see north pole. Here the current is flowing like this, and thumb is pointing towards the north pole.
So
Is that clear now? Chapala.
ఇప్పుడు నార్త్
అర్థమైందా సార్? రైట్ హ్యాండ్ థంబ్ రూల్ సెకండ్ యూజ్. సో ఇది కూడా అడిగే ఛాన్స్ ఉంది, టెక్స్ట్ బుక్ లో ఉంది. ఇట్ ఈస్ దేర్ ఇన్ యువర్ CBSE టెక్స్ట్ బుక్. దిస్ వన్ ఆ fine, that is a solenoid. What do we call him, sir? We call him a solenoid. How to increase the field strength of this?
by increasing more.
Not only two
increasing
two options, there is a separate option for this.
Soft magnet.
You can convert
Soft magnet.
this solenoid into electromagnet and you can further increase the magnetic. How? First is the number of turns story, which you already know. Increase the number of turns, obviously the magnetic field strength will increase. Second, the current. Increase the magnitude of the current, the magnetic field strength will increase. And the third is to insert a soft iron piece inside it and you get your electromagnet. You are magnetizing something. So that's why what do we call it? Electromagnet. If the magnet, like iron piece is not inside, what do you call him? You call him a solenoid. Now when you insert a magnet like iron piece into it, now this solenoid is magnetizing him, so we call him electromagnet.
So very iron still be magnetized if you remove it.
Yes. Steel and iron, see, you remove the iron piece out. Now further two things can be possible. The first thing, immediately it can lose the magnetic effect. Second thing, it will take certain time to lose the magnetic effect. So that is why I think we don't use steel. If steel is inserted, it takes some more time to lose the effect of magnetic field. Okay, sir? We use iron, Fe2O3 to be precise in this. Doubts? Copper, bronze, gold, అన్నీ పెట్టినారంట ఎవరన్నా చలో నెక్స్ట్ సార్ ఇప్పుడు నాకు ఏమైంది రాబాయ్ బార్ మ్యాగ్నెటిక్ ఫీల్డ్ చూడండి దీని మ్యాగ్నెటిక్ ఫీల్డ్ చూడండి అవుట్వర్డ్ ఫ్రమ్ నార్త్ టు సౌత్ సార్ ఇన్వర్డ్ సౌత్ టు నార్త్ సో ఇక్కడ నుంచి మీరు రెండు పాయింట్లు నేర్చుకోండి ఫస్ట్ పాయింట్ the magnetic field of a bar magnet is exactly similar to the magnetic field of a solenoid. First point. Second point, that exactly if you look at the center of the solenoid, the field lines are parallel like this. This is also known as uniform magnetic field. What is it called, sir? Uniform magnetic field. Uniform magnetic field ఎట్లుంటుంది సార్ parallel ఉంటాయి field lines అలాంటిదా uniform. ఇంకోటి ఏం పాయింట్ నేర్చుకున్నాం the magnetic field of a bar magnet is similar to the magnetic field of solenoid. ఇక్కడతోనే ఫస్ట్ హాఫ్ ఆఫ్ ద చాప్టర్ అయింది మొత్తం మూడు హాఫ్ ఇంతకుముందు ఇక్కడతో ఆపేటం కాదు ఇది జస్ట్ హీరో ఇంట్రొడక్షన్ నెక్స్ట్ ఏముంటుండే మనకి లెఫ్ట్ హ్యాండ్ రూల్ తర్వాత మోటార్ తర్వాత రైట్ హ్యాండ్ రూల్ తర్వాత జనరేటర్ ఆ తర్వాత ఆల్టర్నేటింగ్ కరెంట్ డైరెక్ట్ కరెంట్ తర్వాత డొమెస్టిక్ సర్క్యూట్స్ అంత ఉండేది ఇప్పుడు సిబిఎస్ఈ బోర్డు ఏం చేసింది మధ్యలో ఒక పెద్ద చంక్ తీసి పక్కన మీకు మోటార్ లేదు జనరేటర్ లేదు ఏం లేదు సో ఇక్కడ దాకా అయిపోయింది ఇంత పెద్ద చాప్టర్ అంటుండే అందరూ అది వన్ ఆఫ్ ద స్మాలెస్ట్ చాప్టర్ అయింది దానంతా మేము పాపం సరే నెక్స్ట్ సెషన్లో ఏం చేద్దాం లెఫ్ట్ హ్యాండ్ రూలు ఇంకా సెషన్ మైండ్ అప్ ఇక నెక్స్ట్ సెషన్ లెఫ్ట్ హ్యాండ్ రూలు ఏసీటీసీ తర్వాత డొమెస్టిక్ సర్క్యూట్
సార్ మీరు
అరే నువ్వు డైలాగ్ మర్చిపోయావు నీకు
Water.
ఫోటో
Square.